All right, good morning, my pre-algebra class. We're going to go ahead and get started. Go ahead and get out your notes. I'm going to give you a minute here to do that. You need to get your notes out just like today was a normal day of class. So you need a page of notes, and then I'll let you know what we're doing. But go ahead and get your notes out for now, and I'll explain more about this week as you're getting your notes out. A fresh page of notes. So a few more seconds to do that. And I'll just go ahead and tell you for today, we're actually going to do 2 sections of notes together in class on this video. We're doing 2 sections of notes together. And then on Thursday, with your sub on Thursday, you're actually going to do the homework for these 2 sections. So the good news for you is that you don't have any homework tonight. We're just doing 2 sections of notes in class, and that's pretty much it. And then on Thursday again, you'll be doing the homework for these 2 sections. Now, tomorrow, Wednesday, will be more of a normal day for you guys because my sub tomorrow is actually Mrs. Bowman. And Mrs. Bowman, as you know, is a very good math teacher. So she's going to do another section with you, and it will be a normal day. It will be the next section of notes, and you will have normal homework tomorrow night for the section that Miss Bowman does with you tomorrow. So I hope all that's clear. Again, we're doing 2 sections of notes on this video, and then you'll do the homework for these 2 sections Thursday. So hopefully while I've explained this, you've had enough time to get your notes out. I'm going to go ahead and put the header for today's first section. This is 1.2b notes. And this section is on comparing rational numbers. Compare rational numbers. Give you a few more seconds to catch up and get all that written down. All right, so most of what we're doing today, we're basically talking about percents. And all of what we're doing today actually is technically not new for you. This is stuff that we've covered last year in math class. You've probably seen it at least a few times before. So nothing really new here. We're going to be converting percents to decimals and decimals to percents and also fractions to percents in this section. So to start out here, I want you to write this. Write each percent as a decimal. All right, so we'll do a few examples here. Starting with the first example, I want you to write 35%. All right, converting percents to decimal really isn't all that big a deal. Basically, all you have to do is to divide it by 100, which really all you're doing for that is moving the decimal point 2 places to the left. So off to the side here, right next to it, I want you to write the number 35. And technically, again, it's 35%. The decimal point right now, if you think about it, is right after the 5. It's like 35.0. So just write the decimal point there. Again, when we divide by 100, we move the decimal point 2 places to the left. So I want you to write that. I want you to draw like 2 little dips here with an arrow on the end. And that means the decimal point is being moved to the left of the 3. So the final answer is actually just 0.35. And go ahead and circle that as your final answer. Okay, pretty simple, right? Do a couple other quick examples of this. For example, 115%. So once again, I want you to write the number 115 off to the side. And technically, there's a decimal point there. And again, you just move the decimal point 2 places to the left. So again, draw the 2 little dips there. And notice here, it's getting moved between the 2 ones, so that the final answer is 1.15. That's the final answer. So 115% is technically 1.15. Okay, let's do one more example of this. What if I have something like this? Let's say 0.2% or 0.2%. Okay, it's still the same process. I want you to write just 0.2 off to the side here. And just like these other examples, you're moving the decimal point 2 places to the left. But how is that going to look? Well, I would still want you to draw it like that. And notice you've got 2 dips that are empty. And so each of those empty dips, you're going to fill in a 0. So there's going to be a decimal point, and there'll be 2 zeros for those 2 empty dips, and then the 2 afterwards. So that's the answer right there, is 0.002. All right, so that's pretty much that. That's pretty much it. Okay, hopefully that's clear to you. The next kind of problem in this section, you're going to be given a decimal that you will write as a percent. So the directions will say something like, write each decimal as a percent. All right, and this too I would say is pretty simple. It's really just the opposite of what we did in the previous examples. For these problems, you're going to be given a number, possibly a decimal number. For instance, let's just say, let's see here. Let's say 0.83 or 0.83. So on these, you're technically multiplying by 100, which is moving the decimal point 2 places to the right. So if you look here, it's just the opposite. I'm drawing arrows or those dips to the right and putting an arrowhead on the end. And so the answer is actually on this one, just 83, and then add the percent symbol. So it's 83%. So again, we're just moving the decimal point 2 places to the right and adding a percent symbol. Pretty straightforward. Let's do a few more examples. Let's say 0.2, 0.2. So for that, again, you're moving the decimal point 2 places to the right. 1, 2. And notice there's an empty dip there. And anytime we have an empty dip, you fill in a 0. That's going to be 2 and then 0. And then just add the percent symbol. 20% is the answer. All right, one more example of this. Let's say you've got, I don't know, 0.005. Same thing, move the decimal point 2 places to the right. So on this one, in the answer, there will be a decimal point and then a 5. You don't need to put those zeros before the decimal point. Normally, I just leave out the zeros if they come before a decimal point. And then be sure to add the percent symbol. And that's it. It's 0.5%. So that's the answer for that one. All right. So now, the next type of problem. You'll be given a fraction that you have to change to a percent. So the directions will say something like, write each fraction as a percent. All right, in doing this, there's going to be one extra step from the previous examples that we did. So let's just look at an example here. For example, the fraction 3/8, 3/8. So for these, we first need to change the fraction to a decimal, and then we'll change the decimal to a percent. So you should remember how to change a fraction to a decimal. For the most part, you just divide. The number on the bottom, the 8, that goes on the outside, and the number on the top, the 3, that goes underneath the quotient bracket. So it's 8 into 3. Go ahead and add on the 0.0 and put the decimal point up in the answer. So then, of course, you ask yourself, how many times does 8 go into 30? And that will go 3 times without going over. So you put the 3 above the 0. 3 times 8 is 24. And then you subtract 30 minus 24 is 6. All right, so that's not a remainder of 0, so we need to keep going. So add another 0 here underneath the quotient bracket. And then bring that 0 down. And so now you ask yourself, how many times does 8 here go into 60 without going over? And 8 goes into 60, should be 7 times, because 8 times 7 is 56. So write the 50, so put the 7 above that last 0, and then write 56 down here. And then we subtract 60 minus 56 is 4. So again, we don't have a remainder of 0, so we add another 0 underneath and bring down that 0. And so you ask yourself, how many times does 8 go into 40? And of course it goes 5 times. So I write the 5 above this last 0. 5 times 8 is 40. Write that down here. And we subtract. And we finally have a remainder of 0. So 3/8 as a decimal is 0.375. So I'm going to write that over here. And now we just need to change 0.375 to a percent, just like we did before. We moved the decimal point 2 places to the right. 1, 2. And so the answer is 37.5%. So that's how you change a fraction to a percent. You first have to change it to a decimal, and then change that decimal number to a percent, just like we just did. Let's do one more example of this. For example, let's do just 2/3, 2/3. So same thing, we need to change that to a decimal. I'll make my quotient bracket over here. The 3 goes on the outside and 2 goes underneath. So 3 is bigger than 2. We need to add on 0.0 and then go ahead and put the decimal point up in the answer. So now we ask, how many times does 3 go into 20 without going over? And of course it is 6. 3 times 6 is 18. So put the 6 above the 0. 3 times 6 is 18. And you subtract 20 minus 18 is 2. So we need to add a 0 underneath the quotient bracket and bring it down. 3 goes into 20. Well, once again, that's the same as before. It goes 6 times. 3 times 6 is 18. Write that underneath. Subtract 20 minus 18 is 2. Hopefully it's pretty obvious to you what's going to happen here. We need to add another 0, bring it down, so that we have 20. And again, 3 goes into 20 6 times, and it's going to continue doing that. You've probably figured that out by now. 3 times 6 is 18, remainder 2. So I'm just going to stop here. It's obviously going to keep repeating, 6, 6, 6, 6, 6, 6, 6, so on. So off to the side here, what I'm going to do is I'm going to write 0.666. Just leave it there for now. And just like before, we need to move the decimal point 2 places to the right. So let's do that. 1, 2. We'll go right there. So that's 66.6. And then this last 6 digits, the decimal 6, we need to put a bar above that because obviously that decimal digit is going to keep repeating on and on forever. So it's 66.6% with a bar over that last 6. And then add the percent symbol. Don't forget to do that. That needs to be part of your final answer is the percent symbol. So that's it right there, 66.6% with the bar over the 6. All right. There's one last problem from this section that we need to do. You're going to put a set of numbers in order from least to greatest. So I'm just going to oversimplify the directions. I want you to say this, or I want you to say order from least to greatest. All right, and then example. So for these kinds of problems, you'll be given 3 or 4 numbers that you'll need to put in order from least to greatest, but these numbers will be different types of numbers. There might be a fraction, there might be a decimal number, there might be a percent, and so you'll put them in order. So for example, let's just look at this one. Let's say 1/5, comma, 40%, comma, 0.401, comma, and then 4/25. Okay. So, how do we do this? How are we going to put these in order least to greatest? I mean, which one actually is the least and which one is the greatest and in between? To figure that out, what we need to do is convert all of those numbers into decimal numbers. That's the way we're going to do this. Okay, so let's start with the 1/5. To change 1/5 to a decimal, it's a fraction, we're going to divide. I'm going to do that off to the side here. I'm going to put my division bracket here. The 5 is the bottom number, the denominator, that's going to be written here, and 1 will go underneath. So obviously 5 is bigger than 1. I need to add on 0.0, go and put the decimal point in the answer. And then 5 goes into 10, thankfully pretty easily 2 times. 2 times 5 is 10. So we subtract 10 minus 10 is 0. So that's the answer, is 0.2. So underneath the 1/5 here, I'm going to write 0.2. Okay, next is 40%. That one's pretty simple. Once again, off to the side here, I'm going to write 40%. And don't forget, to change a percent to a decimal, you move the decimal point, which would technically be here, 2 places to the left. So that's equal to 0.40, or just 0.4. If there's a 0 at the end of a decimal number, leave it out. So that's 0.4. 40% is 0.4. So over here, underneath, I'm going to write 0.4. All right, now 0.401 already is a decimal number, so I can just write that, 0.401. And then the last thing is to convert 4/25 into a decimal. So off to the side here, once again, make my division bracket. 25, the denominator goes on the outside, and 4 goes underneath. So I need to add on 0.0 next to the 4. I'll go ahead and put the decimal point up in the answer. And so I'll ask myself, how many times does 25 go into 40? And of course 25 only goes into 40 one time without going over. So put the 1 here above the 0. 1 times 25 is 25. And then I subtract. 40 minus 25 is 15. So I'll need to add a 0 and bring it down. All right, and then I need to ask myself, how many times does 25 go into 150? Well, hopefully you can maybe count up by 25s. It's like counting quarters. 25, 50, 75, 100, 125, 150. It goes 6 times. I mean, if you need to do the math off to the side, 25 times 6 is 150. So it goes 6 times evenly. 6 times 25 again is 150, so a remainder of 0. So that's what 4 over 25 is as a decimal, is 0.16. So I'm also going to write that over here, 0.16. All right. So from here it should be easy to tell, now that they're all decimal numbers, which one is the least up to the greatest. The least, the smallest decimal number is 0.16. That was the 4 over 25. And in your final answer, you need to write them as they are in the original problem. 4 over 25 is the smallest. That's 0.16. Okay, the next biggest is the 0.2, which was 1/5. Again, you need to write 1/5 for that. Then comma. Okay, next is the 0.4. That's in the original problem, 40%, so that's what I need to write. Then comma. And then the biggest of those numbers is the 0.401. All right, so that is what your final answer needs to look like. Least to greatest. Okay, and that is pretty much it for this first section. So again, I'm not giving you the homework for this section now. You'll be given the homework on Thursday and you'll be doing it in class. All right, but what I do want you to do now is go ahead and get out another fresh page of notes to do the next section. So I'll give you, again, just a few seconds to do that, to get out another page of notes. And I hope I've given you enough time to do all of the examples that we've done in this first section. If not, you'll have to catch up with someone else. I think you're probably okay. I think I'm giving you enough time here. We're going to go ahead now and move on to the next section. I'll go ahead and put the header on the screen. This is section 1.2c notes. And this section is called the percent, proportion, and equation, which I know sounds weird, sounds kind of crazy, but we'll see what this means. The percent, proportion, and equation. All right, give you a few seconds to catch up on the heading there. And once again, this section, even though the title sounds complicated, this is stuff that you've done in math classes before. This is not technically anything new. So we're going to go ahead and do the problems, the examples for this second section. So for example, you're going to be given a problem that says something like this. 22 is what percent of 110? So let's write that. 22 is what percent of 110? So if you notice, that's pretty much a sentence there. That's a sentence. 22 is what percent of 110? And what we're going to need to do is convert that sentence into an algebraic equation. And so you look at that sentence word by word and you convert it. So let's start with the beginning there. 22, let's just rewrite that underneath. 22, the next word is. when you see the word is, do you guys remember? What do you write that as in an algebraic equation? The word is an equal sign. So write equals. So 22 equals. And then for what percent, just go ahead and write the variable p to represent what percent. So just write that variable p. Okay, next to that, you've got the word of. Now, by now you should know, let's see if you remember, the word of. What operation in math does the word of always represent? The word of always represents multiplication. So go ahead and write a multiplication symbol, just a raised dot there, times, and then write 110. Okay, so that's that. 22 is equal to p times 110. So we just converted that sentence into an algebraic equation. And now we need to solve this equation like we would solve any algebraic equation by getting p by itself. And again, it's just the same process. Whatever operation is being done to the variable in the problem, you need to do the opposite operation to get the variable by itself. So that's p times 110. The opposite of times is to divide, so we divide by 110. And as always, what you do on one side of an equation, you do the exact same thing on the other to keep the equation balanced. So on this left side, we divide by 110. And that will cancel out the 110s on the right side. I'm making a strike through symbol there. And so we're just left with p on the right side. P is equal to, and now we need to do some division. We need to divide 110 into 22. So I'm going to do that off to the side. Divide 110 into 22. And of course 110 is bigger than 22. So I need to add on a 0.0 and go ahead and put the decimal point up in the answer. So now how many times does 110 go into 220? Well, thankfully it goes 2 times evenly. 110 times 2 is in fact 220. So write 220 underneath and then subtract and you have 0. So 0 is your remainder, so you're done with that. So over here on the left I'm going to write 0.2. Now that is not quite the final answer. If you look at the original problem, it's asking what percent, and we use the variable p for that. So if the problem is asking what percent, you need to change whatever decimal answer you get into a percent. So the decimal answer we just got there was 0.2, and remember we were just changing decimals to percents. To change a decimal to a percent, you move the decimal point 2 places to the right, just like I'm showing here. And there's an empty dip, which we'll need to fill in a 0 for that. So that's equal to 20, and then add the percent symbol. So 20% is the answer. So 22 is what percent of 110? The answer is 20%. So that's how you would do that one. All right, let's look at a couple of more examples. For example, this one will be slightly different. You might say this: what number is 80% of 500? What number is 80% of 500? All right, give you a second to finish copying that. right, so once again, this is a sentence, and we need to convert it into an algebraic equation. So we're going to look at this sentence word by word and convert it. Now, one thing different about this one, it starts out, it says, what number? For that, if it's asking what number, typically I just use the variable in. What number in? Then next to that it says is. So again, what do we do for is? What did we do in the last example? For is, we write an equal sign. Then 80% of 500. Now the 80% part, instead of writing 80% next, let's go ahead and convert 80% to a decimal. You're always going to need to do that on these problems. Let's change 80% to a decimal. Hopefully you can do that in your head. If you can't, just remember you move the decimal point 2 places to the left, 1, 2, and that's equal to 0.80 or just 0.8. So 80% is 0.8. So that's the next thing I'm going to write down here is 0.8. So 80% of 500. Again, what operation is of? It's multiplication. So write a times symbol and then 500. All right, and one nice thing about this one, again, we're just trying to get in by itself, and to do that, it's already by itself, so we just need to multiply 0.8 times 500 for our final answer on this one. And so I'll just do the math for that off to the side. I'm going to put 500 on top times 0.8. So we're multiplying like this, 500 times 0.8. And so it's just basic multiplication here. 8 times 0 is 8. 8 times 0 is 0. Then 8 times 0 is 0 again. And then 8 times 5 is 40. And there's one decimal place in the problem, so in my answer I need to come over one decimal place, and so it's 400. So 400 is the answer for that one. 80% of 500 is 400. So that one was a little bit more straightforward. All right, we're going to do one more example here. This will be the last example that we do today. All right, so let's look at this. 14.4 is 32% of what number? All right, so just like these last examples that we've done, we need to translate or convert that sentence into an algebraic equation. So let's go through word by word, starting with 14.4. 14.4 is, what do we do for is? You should know by now, equals. Okay, 32%. Go ahead and write that as a decimal. If you move the decimal point 2 places to the left, that's 0.32. And then of, for of, you should know by now what operation? Times. And then for what number? Again, where it says what number, we're just going to use the variable in. So 14.4 is equal to 0.32 times n. And so again, we're solving the equation. We have to get n by itself. So this one is a little bit extra. So it's 0.32 times n. We do the opposite operation, which is to divide to get n by itself. So we're going to divide by 0.32. And again, what we do on one side, we do on the other side of the equation. We need to come to the left side of the equal sign and divide that, the 14.4, divide it by 0.32. So the 0.32's on the right, cancel out. I'm going to strike through that. On the right side, we're left with n is equal to, and now we're going to have to do a little bit of math for the left side. We're going to have to divide. So off to the side here, I'm putting my division bracket. The number on the bottom goes on the outside, 0.32. And underneath, it's 14.4. All right, now don't forget, for dividing, when we divide like this, you are not allowed to have a decimal point in the divisor, the number on the outside of the bracket. So, this should be review for you guys. We need to get rid of that decimal point. You move it to the right, how many ever places you need to get rid of it. In this case, it's 2 places. Now, the number of places you move the decimal point in the divisor, you also have to move the decimal point in the dividend to the right the same number of places. It was 2 places here in the divisor, so we need to move the decimal point 2 places to the right in the dividend as well. 2 places. So really what we're actually dividing here, once we move the decimal points, it's going to be 32 into 144, and then we have to add a 0 because there's an empty dip there. So add a 0. We're dividing into 1,440. All right. So what is that going to be? So 32. How many times does 32 go into 144? Let's just take a guess. Let's guess 5. This is where we have to use some guess and check here. Let's see what 32 times 5 is. Let's see if that's going to work or not. 2 times 5 is 10. Put a 0 here, carry the 1. Yeah, 3 times 5 is 15, plus 1 is 16. That is too much, as you can see. It's going into 144. So 5 was too much, but 4 will probably work. So let's see what 32 times 4 is. 2 times 4 is 8, and then 4 times 3 is 12. That works. It goes 4 times. So above that last 4 digit, I'm going to put a 4. And 32 times 4, we just figured out, was 128. So I'll write that underneath and subtract. So 144 minus 28, when we subtract that, 14 minus 8 is 6. 3 minus 2 is 1. So it's 16. 144 minus 128 is 16. And then we need to bring down the 0. All right, so now we need to figure out how many times does 32 go into 160. Well, look at that. We already figured that out over here. 32 times 5 is 160, so it goes 5 times. We already figured it out. So I'll write the 5 above the 0 there in the answer. 5 times 32 is 160 even. So we get a remainder of 0, so that means we're done. So 45 is the answer. So I'll write that here and circle that as the final answer. So there you have it. All right, so one thing to keep in mind for this section, that's pretty much it. All of your problems are going to be like one of these 3 examples that we did in this section. Just try to remember, if the problem is asking for a percent, like the first example that we did, I'm going to scroll up here. The first example said 22 is what percent of 110? If it's asking what percent, use P for the variable, for what percent. If it's asking what number, like the last 2 examples that we did, use N for the variable. And if it's asking what percent, like the first example, make sure the decimal answer that you get, that you convert that decimal answer, the 0.2, into a percent. If it's asking for a percent in the problem, if it's asking what percent. All right. So that's pretty much it. And again, you do not have any homework. That's a good thing for you guys. However, on Thursday, I'm going to give you the homework problems, or your sub on Thursday is going to give you the homework problems for these two sections, and you're going to do the homework for these two sections in class on Thursday. And anything you don't finish in class on Thursday will be homework that you'll do that night that will be due on Friday. So hopefully that makes sense. All right, that's pretty much it. And again, as a reminder, you don't have homework tonight, but tomorrow, Miss Bowman is going to be your sub. It will be a normal day. She's going to do one section of notes with you in class tomorrow, and you will have homework tomorrow night. Hopefully you'll have time in class tomorrow to do some of the homework in class like normal, and then you'll do the homework for tomorrow night. All right. So I know we're done a little bit early. I think at this point you should have plenty of time left in class today. For the rest of class today, you guys need to find something quiet to work on. I don't care if you read a book or anything like that, you can do that. If you have homework from other classes that you can work on, you can do that now. Just find something quiet to do for the rest of class. If you guys work quietly for the rest of class, I will let you guys talk quietly for the last 10 minutes. That will be up to the sub, I think Mrs. Vyers. That will be up to her. If you're quiet, then you'll be able to talk quietly for the last 10 minutes. All right, so that's about it. Hope you guys have a good rest of your day, and I will see you guys on Friday.